Hi, everybody. Hello. Welcome, everybody. I'll just give people a chance to join us. I know there's already quite a few people here. If somebody could say hi in the chat and just let us know that everything's working and you can hear us, that would be great. So we're really, oh, hi, everybody. Yeah, lots of responses. So we're really happy to be having this talk today, all about upgrading your heating system with Jo from the Heating Hub. Jo's a qualified chartered surveyor and former heating company owner, and she has over a decade of experience in the UK's domestic boiler market. And Jo, about 3 years ago, founded the Heating Hub, which gives advice to homeowners on how to deal with everything that they need to know about their heating systems at home. Do you want to just quickly introduce yourself, Jo, and tell us a little bit about why you set up the Heating Hub?
Yeah. Hi, everybody, and thanks, Jane and Amy, for having us on. So I ran a heating business. I used to write quite a lot for our website, just wrote about boilers, which is not very interesting, but in the moment that you need to think about it, it's really important to have great advice. So we built up this kind of national following of sort of attracted a national audience to our little local installation business website, and so it's like, actually, is there something here? So when I sold that business, we carved out the website bit of it and just thought, right, we really want to be able to impartially provide really great advice for households, and so that's where we started, really. And then the sort of incarnation of us 3 years ago, as you say, was moving to providing one-to-one advice, but also trying to overcome and I'll talk about some of them in the presentation, some of the shortfalls in performance through the industry as a result of a skills gap, of regulatory failings, of just sort of a lack of impartial advice as well, trying to join the dots up on lots of different technologies that you can bring to your home. So we really felt there was a place for kind of, we wanted to create a trusted place for people to come and bring their unique projects, and that could be making a gas boiler a bit more efficient, or it could be multiple technologies. So yeah, we've sort of sat in that space for about 3 years, and it's really exciting times for us because we want to be able to get our help to more people, and we've just merged with another company called Warmer, who are a tech company. They're sort of everything we're not, super techy, and so there should be some interesting things coming out of that.
That's amazing.
That's us.
Well, no, because it's just such a major part of any renovation, because obviously doing a renovation is just a really natural time to look at your heating system, whether that's because you want to put underfloor heating in, or you're upgrading your insulation, or you're making more space that has to have more heating. So it just really goes hand in hand, but it's not a very obvious advice out there for people to know what to do, other than going straight to their contractors. And sometimes you need that advice a little bit earlier on. And as you say, every project's a little bit unique. So today, I hope that we can kind of talk through, some of the basic knowledge and some scenarios that are out there, so that people can get kind of a grounding in how to even approach this topic during the renovation.
My camera might do that. It's just...
Is it just like to go to sleep?
Every now and I've shut all my other tabs down. Let me make sure I've shut them all down.
We'll probably talk for about half an hour, Jo, and then we're going to do a Q&A session at the end. So people, please feel free to drop questions in as we go along, and we'll get to them at the end. So I'll just hand over to you now, Jo.
Yeah, no, thank you. And I think to that point, you're really, really reliant on the people around you, and so you kind of, the person that comes through your door is the person that you're listening to about what you're going to change in your home heating, and so often we find, and in some, and I certainly wouldn't want to, I don't know, paint them in a bad light, I suppose, but often they're there to sell the things that they like to fit, and that's not always the best thing for you. So I think we're trying to help people take a step back from that and say, let's work out what you need first, and then go and speak to the right contractors. So I suppose the grounding point is a really good one, Jane, because I think when you have a grounding, you can ask the right questions. You know where the pitfalls might be. You know roughly what your project's going to look like, and then when you're speaking to people, you're in a much better position to know whether they are the real deal or not, or they're just selling you a line or not, and you can avoid some real clangers. I wanted to talk through the future of home heating and energy, and I suppose having worked with a lot of people doing a project, as everybody here is probably doing or about to do, or thinking to do, we know the kind of trajectory of that is a very typical one, and you're at a point where you're either extending or renovating, or you plan to do that in the next 5 years, and you think, what do I do now that was not going to jeopardize my future plans? What do I do now that prepares me? Do I keep my boiler if I'm extending? Do I fit a heat pump today? Do I wait 5 years? So I'm going to try and go through some of the sort of typical things that we come across, and how to navigate them.
Oh, sorry, I do this all the time. I press the wrong button at the bottom. That's usually my classic move.
Brilliant. Okay, so this was sort of our opener. Absence of impartial advice can lead to poor buying decisions, and actually, if you can access some good advice, just a little bit of money up front will help you avoid the real pitfalls. And just a bit about us, as I said in the beginning, we can help make your existing boiler more efficient. If you're extending and you're not ready to change your heating, that might be something you want to do. We can help with a heat pump, but we also do a lot of get ready works. What can you do now to get ready for a future renewable heat source? So I just wanted to paint a bit of a picture. I suppose it's really hard for everybody to know what the future of heating looks like, and that literally is the title of the presentation. So the future of heating is a bit sketchy, it's a bit on the horizon, but essentially it's a patchwork. So if we think about today, we've got the national gas grid, and then there's probably about 4 million homes that are off grid, maybe on oil or electric heating, solid fuel heating. But most 22.5 million homes, most of us are on the gas network. Well, that sort of homogenized heating approach is going to disappear. I mean, just to be clear, there's no, even though they're still lobbying, there's no role for hydrogen. So hydrogen ready boilers, hydrogen blend boilers, and they're a complete non-starter. It will be an electric system. They think about 80% of houses will be on heat pumps, about 20% will be on heat networks. So there will be like a communal system. So if you're in a block of flats, or if you're in a tight row of terraces, you may well eventually go onto a district heating system where you've got a large off-site heat pump supplying that street or supplying that block. Now, obviously, electricity is much higher at the moment. We're trying to degas the grid, so the electric power stations are not run on gas anymore. Renewables is very cheap, wind and solar farms, and it can drive prices down if we could restructure how we pay for electricity at the moment. So that's it. I mean, and I think what we'll see is it come down to a very localized level. So there's talk about the future systems operator, who's going to be like a new national kind of operator that will probably devolve decisions down even to a local authority level. So it might be your local authority that's choosing how they're going to roll out low carbon heating supplies. Okay, so I'm going to talk through what size heat source do I need, because it's always a big sort of tripping stone when we're looking at what size heat pump do I need? Do I need a new boiler if I'm extending? I'm going to look at what heat source is right for me. Do I move to a heat pump today? Do I fit another gas boiler? And how do I make good decisions today? And that actually looks across the piece. We're not just looking at heating, because the right decisions might be some insulation. So what size heat source do I need? So it's really common, and I just want to try and put this over first, is kilowatts and kilowatt hours, and it's really common to get muddled up with those two things. So kilowatt is like your kettle has a 2 kilowatt element in it, your oven or your hob will give you 3 kilowatts or 8 kilowatts. So it's just the power output from an electrical appliance, or from any heat source, and it's the same for a boiler. So the boiler will be rated at 16 or 24, it's kilowatts. Kilowatt hours is how many hours of energy do we have to buy per year. So a typical house might use 10,000 kilowatt hours of energy, and the hours is just the number of kilowatts. Let's say you're running a boiler for an hour at 10 kilowatts, its output is 10, so you use 10 kilowatt hours. That's all that is. Okay, so we're going to start with heat loss. So how we work out what size anything you need, because it will be the same for a boiler or a heat pump, is we work out the property's heat loss, and that's determining how well your home retains heat or loses heat, and it's based on its construction. So probably what I would normally do in a live version was say, what size boiler do you need? And feel free to put it into the chat. Most people say I've got 18 or 24 kilowatts, and that's a typical boiler size. So if you have a combi boiler, so you don't have a hot water cylinder, the boiler will be 24 kilowatts or upwards, but that's actually for producing hot water instantly. So it's nothing to do with your heating system. But even boilers that work with a cylinder, they tend to be 18 kilowatts and upwards. But actually you don't need that size at all for your home. Most homes need 6 to 10 kilowatts on a sub-zero day. So when it's -2 outside, your boiler or your heat pump only actually needs to supply about 6 to 10 kilowatts of energy to the home. And that's why heat pumps will work in most properties, because they're available between 4 kilowatts and 16 kilowatts. So up to 16 kilowatts is the majority of homes. If you think very roughly 1 kilowatt per room. So you'd have to have a 16-room house to need a 16 kilowatt, very roughly. We'll see if it's older, you might need a bit more. So I was going to do a couple of examples just to understand the benefits of insulation and how that impacts on the size of the heat pump that you need. So on a modern home, you might only need 3 kilowatts because it's got really good insulation. This home is 100 square meters. And on an older home, exact same, over 3 floors, terraced house, you might need 9 kilowatts for 100 square meters because of the loss of the heat through the fabric of the building. You need a bigger appliance to sort of restore that heat at the same rate that it's being lost. So if you just break that down then, so when we're looking at radiator sizes, if you imagine that, let's say you need 9 kilowatts for your house, and you've got these 5 or 6 rooms, that 9 kilowatts is just broken up across those rooms in your radiator outputs. So helpfully this floor plan, the reception room is a quarter of the house. Therefore, in your 9 kilowatt home, you need a radiator of 2.25 kilowatts in that front room. If you've done lots of insulation, or if you're in a modern home, you can see that actually you only need 0.75 kilowatts. So you can see how that starts to impact on what size you're buying, and then what size radiator you need as well. So understanding that, so you're breaking down what radiators you need, what size they need to be based on the heat loss of your home. And that's a calculation obviously that's done on the fabric of the building. So when you're looking at heat source, we're really looking at the same thing going into the home in terms of kilowatts, and then how much energy it's using to keep your house warm over the year. So I always use this sort of 10,000 kilowatt hour example. Actually, do you want to stop there? We were going to stop at each bit, weren't we, Jane?
Yeah.
Yeah.
So yeah, I guess there's a question here. So I think I'll do this now because it's relevant for here. But Renata's saying, is that 6 to 10 kilowatt valid for any size of home? So I guess what we're saying is you kind of answered that. It's like 1 kilowatt per room, essentially.
Yes.
You could do
yeah. So
so
BTUs. So BTUs is just another way of expressing watts, but the 6 to 10 kilowatts, that's like the average house. So, sort of 3-bedroom semi or 4-bedroom detached, a modest size home would need 10 kilowatts or less on a cold day.
When you're looking at BTUs, is it the same? What does sorry, I should have said this before, Joe. The people on the replay can't see these questions, so I'll just read it out. So he's asking, how does that relate to the BTUs for radiators?
Yeah, so radiator, I think it's an old-fashioned way of, I never work in BTUs, I have to say, I work in watts. So BTUs and watts are a way of expressing how much capacity can come out of a radiator, or how much heat is available from a radiator, and it obviously varies according to the size of the radiator, but also according to the temperature that it's running at. So the BTUs will add up in a similar way, but I tend to use watts and kilowatts because then they're directly related. So
if you're buying a radiator and it says BTUs, if I said what's X BTUs in kilowatts, would that?
There should be a calculator. Yeah, you could probably Google it.
So if the website's not telling you, then you can do your own conversion somehow with Google.
Yeah. Yes, exactly. Google for everything. But it should give you watts and kilowatts. I think The tricky bit is really the temperature that you're running the radiator at, and I do come on to that in a minute, so yeah, we can cover that.
Okay, well, let's one last question now. I always get distracted by them. When you say 10 kilowatts, does this relate to per hour? So
Yes.
if you're saying your boiler's putting out 10 kilowatts,
yes,
it can put out 10 kilowatts per hour. That's what it's capable of.
Yes.
Yes.
Yes. Okay. So it will. So if it runs for 10 kilowatts over an hour, you will buy 10 kilowatt hours of energy.
Yeah. Okay.
But the boiler and the heat pump, in reality, the kilowatt output is going to vary according to the time of day and the time of year. But essentially, when you're looking at your energy bill, it's all of those kilowatt hours added up that it's been running at its different kilowatt outputs.
Yeah. Okay, great. I will let you carry on for the next session and we'll collect some more questions.
Okay. Okay, yeah, so when we're talking about what heat source is right for me, then really it's coming down to probably what you're ready to do. So I think that the important thing to point out at this point is that heat pumps will work in pretty much all homes. I think if the home is greater than 16 kilowatts, which is the top end of a domestic heat pump, and it's the top end because of its how many amps it needs. It's a sort of it needs a lot of the capacity in your electricity meter to run, so it can't get too big. After up to 16 kilowatts, you can fit a heat pump. If it goes over that in the home, then you might be looking at a hybrid, just because you don't have the capacity to run it in cold, have enough kilowatts in colder weather. So for most people, I think you can say you can almost definitely have a heat pump. There's obviously some space issues, which I'll come on to. There's some efficiency issues, so running cost issues, depending on how what temperature it's going to run at. But in theory, most people can have it. So the questions are really, I'm at this juncture of I'm about to do some work or I'm doing some work. Do I retain my boiler? Do I fit a new boiler, or should I be moving to a heat pump at this point? So that's what I'm kind of going to cover in this next section.
Great.
So the first thing I tend to go through here is some boiler myths. So lots of people think I've got a 10-year-old boiler. My plumber's told me it's not big enough for the new home. I'm going to have to replace it as part of these works. So there's just a few sense checks here. So the first thing is that boilers should last 22 years, and I've just made representations to government on this because I think it's so endemic that even boiler manufacturers in the UK say lifespans are 10 to 15 years, and the same manufacturers in Germany, the same manufacturers say 15 to 20 years because they have a culture of retaining their boilers for much longer. So we have a culture of premature replacement in the UK. They should last 22 years. Parts are available on boilers up to 20 years and older. You can get onto maintenance contracts with older boilers as well, and they'll support you. So there shouldn't be many reasons why, unless you have a multiple parts failure, that you need to change your boiler. So 22 years. If you've got a boiler that's 15 years old, in theory, you've got 7 years to go to get through to fitting probably a heat pump at the same price. Then there's some of my evidence of 10 to 15 years. Yeah. It means that, and the culture of over replacement is there in the age of our boiler stock. So we've got 75%. This is from the English Housing Survey. 75% of boilers are 12 years old or less. I mean, that's an astonishing number, really. I don't know if I say it on the next slide. Well, 27% are 3 years old or less. So every 3 years, we are replacing a quarter of our boiler stock. It's a huge industry. 90% of homes already have an A-rated boiler. So A-rated boilers are the most efficient you can buy. They've been mandatory since 2005. If you're changing an A-rated boiler for another A-rated boiler, you're not really going to save any money. You might save a little bit. You've got just as much chance of making your existing boiler more efficient, and that will save you the same amount of money for a lot less. I'll come back to that slide again. That's my sizing slide. Okay, so I think I was going to go over a typical house in terms of, should I retain my boiler? Do I need a new boiler if I'm extended? So I found a typical extension with an enormous 2-story side extension. So you're almost doubling the size of your house. So the existing house is around 7 kilowatts. What you're adding on is 2 kilowatts. And to go back to that previous slide, as most people have 18 kilowatt boilers or more, there's almost always more than double the size of capacity in your existing boiler. Now, as I said at the beginning about combi boilers, so if you don't have a hot water cylinder, your boiler will say 24 kilowatts, and that is for hot water production. The heating side probably around 18 kilowatts. So almost every home has a boiler that will see them through even an extension that sort of doubles the size of their home or more, because if you think how well insulated your extension is going to be, it's a fraction of the heat loss compared to your existing home. Now, I spoke just briefly about heat pumps being suitable for every home, and there was a electrification of heat project. This was carried out by the Energy Systems Catapult, and it says there's no property type or architectural era that is unsuitable for a heat pump. And these were the findings. And as I said, there obviously are some barriers, but essentially they will work in every type of building. Now, I was going to go through some principles of a heat pump. So for those that are not so familiar, for every 1 unit of 1 kilowatt or unit of power that you're putting into the heat pump, so not kilowatt hours, but kind of the same thing in this case, for every 1 unit you're putting in, you want to get 2 to 5 units of heat energy out. So 1 kilowatt of electricity gets 2 to 5 units of heat energy out into your home. And that's why our 10,000 kilowatt hour example, you're actually only buying in around 3,500 kilowatt hours of electricity. So 3,500 kilowatt hours of electricity is giving you 10,000 kilowatt hours of heat energy. And this is why heat pumps can run, be close to the price of a gas boiler. I think it's on my next slide. Yeah, so if you're, and depending on whether you get 2 units out or more typically 4 units out, they don't have to go up to 5, depends on what you pay. So if we think that the cost of electricity at the moment is 27p per kilowatt hour, you're buying 1 unit and getting 2 free, then you're getting you're paying £1,350. If you're getting 4 units out, so you're buying 1 unit and getting 4 units of heat energy out, your energy bill is half that. So the efficiency of the heat pump is really important. Sorry, because it impacts on your energy bill. And I think my next slide is gas. No, it's not. I'll go back in a minute. So a gas boiler. If you flip it round and say electricity is 27p per kilowatt hour, and if I'm dividing that by 3.3, it comes down to close to that of a gas boiler. Sorry, 27p for electricity. Gas is currently 7p. So 3 and a bit. If you divide by 3 and a bit, so if you've got 1 unit of electricity becomes 3 and a bit units of heat energy, you come down to price parity between a gas boiler and a heat pump. So the efficiency is going to determine whether you pay more or slightly less than your current gas boiler. And it is not really a secret that heat pumps are not cheaper to run than a gas boiler. Quite difficult to get that. However, when you start combining with solar and batteries and time of use tariffs, actually there are really decent savings in there.
Okay.
Do you want me to answer that question?
Small question?
Yeah.
Well,
yeah.
I've got a question first. So just to kind of recap what you were just saying. So if you've got a gas boiler, you're buying 1 unit of gas, and you're getting 1 unit of heat out.
You're actually getting probably 0.8 of a unit out because of the inefficiency of the boiler. Yeah. Yes,
okay.
Absolutely.
So that's what we're dealing with, and so we're getting more units of heat out with the air source heat pump, and how much we get out depends on the heat pump, the location, the efficiency. There are factors affecting how much you're going to get out of that heat pump.
Yes.
But also what you're saying is gas right now is cheaper than electricity.
Yeah.
So even though you're getting more energy out, like per unit you're buying, you're saying it's at the moment it's kind of comparable.
Yes.
Between the two. And is that going to be the same going forward, or do you see that will electricity prices come down in the future, or gas prices go up?
I don't know about gas prices because the thing is gas and electricity and gas prices are linked. So when gas goes up, electricity goes up because the electricity price is set by the highest cost of generation, which is from gas, and we're still using gas to generate electricity. So at the moment they're tied together, so it does need a major restructuring. but the cost of generating electricity from solar and wind farms and even nuclear is much lower. So as we move away from gas for generating our electricity, we move to a low carbon or renewable energy mix to create electricity, then that will drop, and then it won't be so critical to achieve a great efficiency from the heat pump, which requires reducing the flow temperature to the system, which requires either lots more insulation or larger radiators. So there's a sort of bigger investment to try and bring those prices closer together.
Okay, I can see we've got quite a few questions here.
Yeah.
I'm just going to pull up a couple. So Renata's saying, can you give an example about an efficient boiler? So in that slide that you have there, if you had an efficient boiler, where
would it sit price-wise?
Yeah.
Yeah, it would probably sit about £700.
Okay.
Yeah.
So somewhere in the middle of those,
yeah.
just above the 4 years. Okay.
Yeah.
Do you have any information about comparisons with oil boilers if people aren't on the gas grid?
Yeah, so it makes, I mean, the price difference is smaller on an oil boiler because you're paying a higher price per kilowatt hour for oil. And there's other, I suppose there's other installation costs as well, because if you're changing your oil boiler, sometimes you have to change your oil tank, and there are, there's lots of, I suppose there are lots of there are a greater number of maintenance requirements around an oil boiler, and a greater propensity, I suppose, for it to break down and get blockages. And so there's probably a better case for changing out an oil boiler for a heat pump. It usually saves more money and reduces, improves fuel security, reduces your liability because you're not open to spillages and maintaining an oil tank. So it's probably a better case than a gas boiler for oil.
I've got one more with similar. Electric boilers are more efficient, ? Is that the case?
Yes, they are. So if we go back to a gas boiler being 80% efficient, an electric boiler is 100% efficient. So there's no energy loss through the fuel burning process. So gas boilers throw out about 20% of the energy that you buy through the flue because of the combustion process, whereas electric boilers just run very efficiently. However, if we go back to our 10,000 kilowatt hour example on our price range here, we're not getting any multiplier of efficiency from an electric boiler. So you're basically paying 27p per kilowatt hour for your 10,000 kilowatt hours of electricity. Therefore, even though you reduce it by 20%, so you're buying 8,000 kilowatt hours because you've got rid of 20%, you're then multiplying it by 27p, which is,
okay,
probably £2,000-ish. Yeah,
that makes sense. I've got a similar, my brain's whirring in a similar way. I only remember from being at college. But, we're with you, I think. Right, here we go. One more. What's the differences between air? Do we come on to this, or the differences between air and ground source heat pumps?
Yeah, so air source, it's a unit externally. It's pulling in air and taking latent heat from the air and converting it through its internal processes into usable heat for the home. A ground source uses ground loops, so it has loops that are trenched into the ground. So it's a lot of groundworks, usually a fair amount of land that you need, and that's taking heat from the earth. And actually, it's a much more expensive installation. It makes sense if you're building, on a kind of greenfield site and trenching it all up anyway. But otherwise, it's very expensive. The upside of it is that it's more efficient. So whereas heat pumps have to work with temperatures in minus temperatures and work very hard then to create warm energy for the home, from the ground, it doesn't matter on the weather. It's always a fairly stable 12 degrees. Therefore, the work that it's got to do to bring it up to temperature is much less. So it's much more efficient. But usually, that doesn't make up for the higher upfront cost of fitting it.
Okay, one more, and then we'll carry on. Due to low temperature output from air source heat pump, do you need to retrofit, insulate the existing house to keep the heat in?
Yeah, but this comes. I might be coming on to this now, actually.
Okay.
So
let's carry on and come back.
Yeah, okay. Yeah, we'll come back to that question if I feel like I've answered it.
Okay.
Yeah, so whether you get 2 units in or 2 units out or 4 units out depends on your insulation. So there's obviously a couple of ways of dealing with that. If you've got cavity wall insulation, it's a really low cost measure. It's not intrusive, it's all done from the outside. You may think you've got cavity wall insulation, and you can get what's called a sort of borrow hole, I think, which is someone that come and check, or they can do a sort of thermal imaging camera to see if you've got any patches or it's all dropped to the bottom. So you can have it investigated. Obviously, the more expensive route is solid wall insulation, and that can be internal or external. External, very tricky if you've got pretty London terraces and lots of ornate features. Internal means you lose some vital space, so it's not for everybody. And certainly insulation is really important where it makes sense, but we've moved on from heat pumps don't work in older homes sort of position, because originally they did only run at very low temperatures, so you needed lots of insulation, as you say, to keep the heat in, and for it to run at a low temperature and still keep you warm. But heat pumps are increasingly available at much higher temperatures. They can run the same as a gas boiler. They're less efficient, so we're probably going towards the 2 end rather than the 4 end if you need to run it at a high temperature. But essentially, the cavity, I don't think, and someone put a tweet up recently actually, and we're kind of forming the view that it's not fabric first anymore necessarily. Fabric first is, it definitely should do it when it makes sense. It shouldn't hold you up moving to a heat pump, or it shouldn't necessarily hold you up. There are the quickest decarbonisation wins are changing your gas boiler for a heat pump. So if that's your motivation, you can do that now.
Just for people who don't know, fabric first is the concept that you should insulate your existing home, walls, floor, roof, do everything, windows, everything you can first before changing your heat source. Yeah.
Yes, and I think that's, we should still be thinking about fabric, but it's not necessarily the thing you do first. I think now you could do it fifth, and So, and the reason they can work in any home, and the reason you don't have to insulate now, is that where you can insulate no further, radiators can get bigger to compensate, or you can add more radiators. So this is about flow temperature now. So it's what flow temperature are we going to achieve from the heat pump? And as I said, whether you get 2 units of energy out or 4 units of energy out, it's about the flow temperature. So going back to sort of radiator sizing again, there's 2 aspects to radiator sizing. The first one we talked about was about the fabric of the building. So how well insulated is your home? Do I need to fit a 0.75 kilowatt radiator in that lounge, or do I need to fit a 2.25 kilowatt radiator, whether I've got a 3 kilowatt home or a 9 kilowatt home? And you can insulate your 9 kilowatt home and bring it down closer to 3, and then you're reducing the radiator sizes. But radiator sizes are also dictated by flow temperature. So in the picture you can see an 80 degree flow temperature will get you 1 kilowatt of heat from that much smaller radiator. If you drop the flow temperature to 50, which is what we want to run a heat pump at, you will need a much larger radiator to get the same amount of energy into the room. So they're both giving you 1 kilowatt of heat, but they're doing it at different flow temperatures. And this is why when you have older homes, period homes, single glazing, solid wall, you already have to have a big radiator, and then it has to get a load of times bigger if you want to run the heat pump efficiently. But as I say, even that is becoming slightly out of date when standard manufacturers are offering heat pumps that can run up to 70 degree flow temperatures, and they achieve a reasonable efficiency actually, and it's only 70 on the coldest days. It's not all year round. And similarly for underfloor heating, if you think about underfloor heating in your extension, or running it throughout the downstairs of the property, that's quite a common scenario. Just as you need more surface area of radiators to achieve a low temperature, so you need more pipe to do the same. So underfloor heating can be laid as close together as 100 millimeters and as wide as 300 millimeters. So the space that it's set at will determine how much pipe you've got in the floor, which will help you reduce the flow temperature. So quite often now, some underfloor heating companies will just design for 100 or 150 degree pipe spacing, because it just overcomes all eventualities. Do we want to stop there and do a bit more on questions?
Yeah, no, that's so interesting. I've never thought about the fact that how you space your pipes in your underfloor heating is the equivalent of having kind of a big radiator or a small radiator, and how that flow temperature works. So that's really interesting to know.
And I think it's probably just worth pointing out there, Jane, whilst with underfloor heating, because you can't walk on a really hot floor, obviously your flow temperatures are capped at 50 anyway. So, but you are automatically getting a lot more surface area into your space to run at a low temperature.
Yeah. So what I'm understanding is like your radiator size that you have in your house when you've obviously done that calculation you did at the beginning, and then if you're insulating at the same time and you're really improving the insulation of your house during your renovation, that radiator size can come down because you're not losing as much heat. If you are then installing an air source heat pump and reducing the flow temperature that you're working at, that radiator could go back up.
Yes. Yeah.
So potentially, if you're doing both of those things, it might even out and be around the same size. But then also, if you're using a massive radiator, like the equivalent of underfloor heating, in a way you're getting out of that problem because you're already using a type of heating that requires a low temperature to run. Yes. So it's a no-brainer. If you're insulating and you want underfloor heating, then an air source heat pump it does kind of make sense in that scenario, doesn't it?
It makes total sense. I think our advice tends to be kind of do all or nothing. I think lots of people do want to put underfloor heating into an extension, and actually that is really valid. I think if you look at that picture on the right there, is it on my right? You're right, but on the right there with the sort of bifold doors, they've obviously extended and then they've brought that back into the rest of the house, and you end up with two slightly different systems maybe. But I think there's definitely a case for if you're going to put underfloor heating, to try and do the whole of the downstairs, or probably do none of it. Small amounts of underfloor heating. It can be problematic for installers to join it up properly with the rest of the system. I think don't be afraid of, but I also think don't be afraid of not putting underfloor heating and still fitting a heat pump. Both can work.
Okay, we're going to do a couple of questions. So Justine's saying, at the home building renovation show, there was a stand advocating cork spray interior or external insulation that is less intrusive. How could you work out the insulation value before you commit?
Yeah, that's interesting. Well, I mean, so we roughly know what the U values are. In fact, you would hope they'd be able to tell you what the add-on is for your home. But if you've got a solid wall, the U value is about 2.2, and if you've got a cavity, uninsulated cavity, it's like 0.8 or something. As the minute you've got cavity walls, you massively slash your heat loss. So U values are basically the way in which we measure or calculate how quickly the heat is lost through the fabric of the building. So higher is worse. So solid walls 2.2, 2.3. Current standards, so when you're building to current standards, it's 0.3, and sometimes you can get it below. So you probably want to try and understand from the manufacturer, well, I'm putting it onto a solid wall, therefore what does my U value come down to? And I'm not an insulation expert, but I having done some reading into it, I know that on solid walls, when you're solid wall insulating, they try and keep it above 0.7. So you don't bring it down to current standards, basically, you keep it slightly higher. And when you know that, that then goes into the heat loss calculation that will deliver you your kilowatt figure. Yeah.
How can people get that calculation done? So how can you find out what your house will, in its existing state or future state, would need?
Yeah, there's some little, I mean, we use an online calculator, although we subscribe to it, but I think you can use it as an individual as well. And I want to say there's a free one on there as well that you could probably use. But that you can use a little calculator. As long as you know what the construction is of your home, it will automatically add a U value. You can also, I think you can get it done. So if you go down a heat pump route, the installer or someone who works with the installer will absolutely carry out heat loss calculations. So that will be a site visit and just putting every sort of building fabric in your building into a calculator, so it's a bit more detailed. Yeah, so you could probably get a rough and ready one. I can put it in the chat.
We could share it later, Jo.
Yeah, do you want to share that later?
It's like an interesting step from knowing what you have to what what your situation is. So I've got another question. So underfloor heating is more efficient? Question mark.
Mind
blowing.
Yes, it is in the set, but it doesn't mean that you can't achieve the same with radiators. So surface area is surface area. So if you can achieve a 50-degree flow temperature in your underfloor heating, you can size your radiators to run at 50-degree flow temperatures. The benefit is the same. So yes, it's more efficient. And just to say that the same extends to your gas boiler. If you can run your gas boiler at a lower temperature for heating, it will also run more efficiently. And the gains are much less because we're talking about from 80% to 90%, so it's only 10% gain. Whereas the multipliers for heat pumps are much bigger. It's 2 or 3 times the output. So 200%, 300%, 400%.
One more question before we move on. So heat pumps can cut costs by 50% approximately. Is that really what we were?
I'm sorry, I might have led people astray there. So no, it doesn't. They're likely to, if they're running at a reasonable efficiency, cost the same as a gas boiler to run. However, if you factor in, if you have solar panels and a battery, and you can use time of use tariffs where you might charge the battery up overnight or run the hot water overnight when it's very low tariffs, and then use and then use that during the day, use stored heat and stored energy that can be charged up overnight on low tariffs and then used during the day. You sort of end up brokering your energy a little bit. Then electric heating system combined with all that can produce a sort of 50% saving across your whole energy bill. So for gas and electric, but on its own, heat pumps, no.
Right, that's good clarification. Renata's saying she got confused by the 2 units times 4 units slide.
Oh, I see. Yeah, sorry.
Right. Yes. Okay. No, good to clarify. And I guess what's good that I'd never really twigged that if you have a gas boiler, and then of course you can add solar panels and a battery to your property, but they're not working in conjunction. One's not feeding the other, so you would only be feeding back to the grid if you had extra, or using it for your other electricity. So it's about that combined, like both being on the same system, that you get the benefits.
Yeah, it's about whole home electrification. When you've completely moved away from gas, you get the biggest benefits of all the technologies.
Okay, so shall we carry on?
We can carry on. Okay, so logistics. Where do we put it all? Locating the equipment. So there's a few examples there of heat pumps and internal units and how they can be kind of divided up across the home. So for example, the 3 units on the left, the one is a wall hung unit. So the black box there in the middle is obviously the external heat pump. The wall hung one is part of that heat pump. It's like the internal. It's called a split system. And then you would also need a hot water cylinder with that particular setup. The 2 on the right are some of the internal components and an internal hot water cylinder. So sort of a fridge freezer size unit that can slot in somewhere. And they're increasingly trying to come up with creative ways of accommodating the stuff in our houses, because we've all got combi boilers. Most of us have got rid of our hot water cylinders, so we've got to kind of crowbar this stuff back in again. So we're trying to do that in the least intrusive way. So just a few notes, I guess, on where you site them externally. They come under permitted development, so you can fit them without planning permission, but there's a few boxes you have to tick. So it needs to be a metre from the boundary, and ideally, I always say close to the house, because that's going to be the lowest cost installation. And there's a few other places you can put it. So it doesn't you can see that one on the right is on the boundary, so you can do that, but you would need to apply for planning permission. Some people have put them down the garden a bit. If you do that, then you have to trench back to the house to take the pipework, obviously back to the heating system. But they can be tucked in lots of different places. I think my next slide is getting really creative. So on a flat roof, and actually that's a reality for lots of terraced houses, even that got a flat roof on the back of an extension. Down the garden again, or it can be wall hung. With the wall hung versions, it can't be wall hung on the front of your house, not that you would want that anyway, but you can put them on the front of your house. There's absolutely nothing stopping that if it's at ground level and you're not in a conservation area. There's some grant funding available. So in England and Wales, if you're replacing a gas boiler, oil boiler, or electric heating system of any sort, there's £7,500 grant. There's also some funding available for insulation, which will cover solid wall and cavity wall. I actually applied through an energy provider. It's been really slow, so it really launched quite recently. I was sort of testing it really to see what the experience was. But if you have a property that is council tax band A to D in England or A to E in Wales, and you have an EPC that is D or below, you can qualify for probably some top-up funding under the Great British Insulation Scheme, and that's via the government website. In Scotland, they're much more progressive. So as well as the grant, you can get an interest-free loan. There's also the same grant levels for solid wall insulation. There's loans for solar panels. You go to Home Energy Scotland website to do that one. Do you want to go through a couple more questions?
I think like we're probably coming
quite near the end.
Time, so
yeah.
let's try and finish, and then we can wrap up at the end. So
how to make good decisions today? Do I retain my existing boiler, or do I fit a new boiler? Well, the kind of answer on that is, how old is your boiler? And is my house getting bigger than its capacity? And the likelihood is no. I mean, there's lots of questions around moving it. So you can move a boiler. So often it's coming out of the extension that you're building, or coming out of the kitchen that you're extending and going somewhere else. So you can move it. There is a bit of a risk. Sometimes it needs a new flue. But yeah, someone willing to do that for you can usually make that happen. Fitting a new boiler won't save you any money, won't be much more efficient, will cost you £3,500 and upwards. That's money that you could spend elsewhere, and it will have no impact on your carbon footprint. Whereas cavity wall insulation, loft insulation, even upsizing radiators, you could do with that 2.5 to 3.5K budget, and will have an impact on your energy use and also the efficiency of your system. This is quite a helpful little guide, because I did a lot of research into EPCs and the impact of different measures, and I think that's quite telling. So cavity wall insulation is the biggest single impact you can do to reduce your energy or your heat loss. 9 to 11 points on an EPC, and it's £1,000, and you might even get some grant funding. Solar PV, again, really high impact, £5,000 to £7,000, pays for itself really quickly, perhaps 5 years. Or 5 to 8 years, depending on what you fit, 7 to 11 points. External wall insulation, massive impact, but high installation costs. I think what was most interesting was moving from single glazing to double glazing was a lowly 3 points, even though it's quite an expensive thing to do, and doesn't really save you very much money either. So just in terms of understanding where your money goes, that's quite a decent guide for value. And I think that is my last slide.
That's amazing. I think there are just a few questions left, but I think they're a little bit more detailed, and I might connect you and the questions after the talk, if that's okay, guys. And I just wanted to say, so my feeling from all of this is like lots of great information, and I want to work out my energy use, and I'm going to do some calculations. But if I just feel a bit lost, this is what you do, isn't it? You help people through this process of getting advice about their heating system and what's right for them. Is that right?
It basically is, yes. How I can speak with any authority. I'll just talk about it every single day. Yeah, so we were looking at someone's house today, what their energy use is. So we look at their energy bills, what they plan to do, they extend it, insulate it, look at their radiator sizing. Yeah, what's the feasibility of a heat pump today? How old is the gas boiler? What can we do to make it more efficient? So everything I've kind of talked about is what we're providing one-to-one advice on.
Yeah, it's just brilliant because it is so important, and it sometimes comes as an afterthought because we're thinking about the space we're creating, and then
Yes.
it's like, okay, well, what are we going to do? And by that point, it feels a little bit too late. So it's such big amounts of money, and it's such a long kind of time span that we're thinking about covering, you know, investment for the future, that, you know, I just feel like it's a really important step. And I hope that if anybody takes anything away from this talk today, is just get your homework in and try and work some of these things out before you end up on site. Because at that point, it might be a little bit too late to change your plan or what you're doing and see if you can make the best savings. Yeah. So thank you so much for today, Joe. It was lots of information, but the replay is going to be available. So if anybody wants to rewatch or relook at slides and go back over that, they definitely can. And yeah, get in touch with us, get in touch with Joe if you have any follow-up questions. Okay, thanks, Joe. And we'll let everybody else go and get their lunch. Thanks for all your questions. Bye, everybody.
Bye.